Today we'll be doing session 2, which is linear equations and probability and statistics. So let's get started. Right, so solve the equation. So we have 4x minus 5 plus 7 times x plus 1 equals 6x plus 7. So when we're talking about solving a linear equation, what we want to do is we're trying to essentially solve for x. Right? So let's do that. When we see a linear equation like this, the first thing we need to know is we need the order of operations. Order of operations is represented by P, E, M, D, A, S, or PEMDAS, right? That stands for parentheses, exponents, multiply, divide, adding, and subtracting. This is the order we want to do things when we're solving an equation. So we look at our equation, and we see that we have a parentheses here, right? The parentheses, we have x plus 1 in our parentheses. The x plus 1, you can't add x plus 1, so we move on to E. E are exponents, but exponents are powers. In this case, we don't have any powers, so we move on to the next one, which is M, which is multiplying. We see we have multiplication going on because we have 7 times x plus 1. So what we're going to do first is we use the distribution law. We distribute the 7 into everywhere we have in our parentheses. So this will look like, if I rewrite the whole equation, I have 4x minus 5 plus 7 times x, 7x, 7 times 1 is 7, is equal to 6x plus 7. Now, I want to look at, before I do anything else, I want to see what I can combine, what like terms I can combine. So I see 4x plus 7x, they're both x's, so I'm allowed to add them. 4x plus 7x is 11x. I have negative 5 plus 7, that is a positive 2. And that's equal to 6x plus 7. Now, what I want to do now is I want to solve for x. That means getting x all on one side. I have an x on the left and an x on the right. So what I do is I want to consolidate them on one side. I notice that 11x is bigger, so I want to keep that 11x over there and bring this 6x over. We bring that over by getting rid of it, and we do that by doing the opposite of it. Because it's a positive 6x, we subtract 6x. And when we do one side of an equal sign, we always have to do to the other. So on the right side, these cancel out. 11x minus 6x gives us 5x. And we write plus 2 equals a 7. And okay, again, we want to get x by itself. I have a positive 2. We want to get rid of it by subtracting 2. So I subtract 2 both sides. Again, this is gone. So I'm left with 5x equals to 5. And my last step is I have 5 times x. I need to get rid of the 5 because I want just x. I get rid of the opposite of multiplication is division. So divide by 5. What I do on one side, I do to the other. So I end up with x equals to 1. I'm going to go ahead and write down here in my box as x is equal to 1. So that's our answer. So let's erase this and go back to the answer and see if that's correct. So our answer is x equals 1. Okay. So let's erase that. Next one. So write the equation of the line in slope-intercept form with the line passing through the point -1, 4 and m equals to 2. So what we need to know is this is define the slope of the line, right? So we have the point -1, 4 and m equals 2. So we have -1, 4 and m equals to 2. So what does that mean? So this is we need our answer in slope-intercept form. So what we know is slope-intercept form. That form is always y equals to mx plus b, where m is called your slope, while b is your y-intercept. Y-intercept is the point where the line, your linear equation, crosses the y-axis, and that point is always represented by 0, comma b. Now, if we look at our point is not a 0, comma b, it's -1, 4, so it's another point that's on our line. So there's another equation we need to know called the point slope. The point slope form is the form when you're using whenever you have a point and a slope. That is represented by y minus y1 equals to m times x minus x1. Where x1 and y1 is your point, while m is your slope. So we label this as x1, y1, and we plug everything in, right? So we keep y and x as it is, so we do y minus, our y1 is 4, equals m, which is 2, times x, our x1 is a negative 1, so we minus 1. So now we solve for y, because we want our answer to look like y equals mx plus b. So, first thing is follow order of operations. I see, look at inside the parentheses. What can I do with it? I see that I have a negative, negative. Two negatives gives us always a positive, right? Let me write this 1 minus 4. And move on to my multiply. I can distribute this 2 into everything. So this becomes 2x plus 2 and y minus 4. And because I want y equals, I want to get rid of this negative 4. I get rid of it by adding 4 both sides. So y equals to 2x plus 6. So I'm writing down here my answer. Y equals to 2x plus 6. So that should be our answer in slope-intercept form. Okay, so let's see. There we go. Y equals to 2x plus 6. Okay, so find a solution, if there is any, of 20 equals to 16 minus w plus 6 all over 2w. So let's solve that one. So first things first is we have a fraction here, right? What we want to do is we need to get rid of them. We want to get that fraction by itself first. So first off, let's get rid of that 16. So I get rid of 16 by subtracting 16 both sides. When I do that, I'm left with 4 equals negative w plus 6 all over 2w, right? So now, I have a negative w plus 6 over 2w. I don't like that negative over there, so let's, for simplicity's sakes, let's multiply both sides by just negative 1. Because in doing so, we're going to be flipping the signs of these two. So now this becomes a negative 4, and this equals to a positive w plus 6 over 2w, right? Now, we want to, when we're solving fractions, we want to get rid of the fraction. Easiest thing we do is, let's say we write any whole number as over 1. In doing so, we have a fraction equal to a fraction now. And when we have that, we can actually cross multiply. So we cross multiply this times this. So let's write this as 2w times negative 4. That's negative 8w equals to 1 times w plus 6 stays as w plus 6, right? So now we got rid of our fractions. This becomes just a standard linear equation. So we want to solve for w. So we want to get w on one side. So I would subtract both sides by w to bring it over. So I get rid of my right side, keep all my w's on the left. Negative 8w minus 9w, minus w gets us negative 9w. That's equal to 6. And I want to solve for w, so I divide both sides by negative 9. So I would get w equals to negative 6 over 9. But in math, you always want to reduce your fractions, right? So I look between 6 and 9, they can both be divided by 3. So when I divide by 3 top and bottom, in reality, I get w is negative 2 over 3. So you always want to write, you always want to reduce your fraction at all times if you're able to. Right? So our answer is w equals to negative 2 over 3. Let's see if that's the answer. There we go. Negative 2 over 3. Right. Next one. Okay, solve the equation by clearing the fraction, right? So the key thing is saying clearing the fraction. So let's see what we do in order to clear the fraction. So, first thing we do is, before we want to clear the fraction, we need to find something in common between all the fractions. The thing in common is called the LCD, which is called the least common denominator. Least common denominator, it means the most common denominator between our denominators, our bottoms. So if we look at the denominators, 6, 4, and 12, we want to find a number that can be divided by all those numbers. The smallest number possible we can divide by, can be divided by 6, 4, and 12 is 12, right? Because 12 can be divided by 6, 12 can be divided by 4, and 12 can be divided by 12. So now what do we do with that, least common denominator? Well, the question's telling us to clear the fraction, right? So to clear the fraction, what we do is we take this whole equation and we clear it by multiplying by our LCD, in this case 12. So we multiply everything by 12. So in doing so, I'm distributing this 12 to every single term on the inside of my parentheses. So this will look like 12 times 1 over 6x plus 12 times 3 over 4 equals to 12 times 1 over 12x minus 12 times 3 over 12. So all I did was I distributed 12 into every single term inside my parentheses. Okay, so now we want to simplify. So if you want, you can treat these as 12 over 1s to make things easier when you're multiplying. So I can do, when I'm writing fraction, I can actually cross divide. So I do 12 divided by 6, that gives me 2x. And then I could multiply by 3 first, but I can actually divide at the same time if I wanted to. So I can do 12 divided by 4, that gives me 3, times the 3, that gives me 9, equals to 12 divided by 12, that's 1, but it's still an x. So that's just x. I have a 12 divided by 12, that's 1, times a negative 3 is a negative 3. So what we just did, we just got rid of all our fractions. That means by clearing it, right? Because you want to make things easy for yourself. You don't want to work with fractions. You want to get rid of them as soon as possible. So now doing that, this just becomes a linear equation that we solve for x, right? So I have 2x and x on both sides. So I want to bring it all to one side. So I subtract x both sides to get rid of the x on the right. 2x minus x gives me just an x plus 9 equals to negative 3. So solve for x. I subtract 9 both sides. So x equals to negative 12. So our answer is x equals to negative 12. Okay. So let's see. X equals negative 12. All right. Next one. Okay. So find solution if there is any of 3x minus 5 bracket 4x minus 7 times x plus 2 close parentheses bracket equals 106. Okay. So this one we're introduced with a new notation or a new form. We see brackets. Brackets are just another way of writing parentheses. They just want to have a difference between, because if you write parentheses twice, sometimes it gets confusing. So what they did was they wrote brackets twice in order to differentiate it from the other parentheses. But it serves the same purpose, right? So let's write in the corner here what we need to use. Remember PEMDAS, right? Order of operations, right? So P, we always want to deal with our parentheses first, right? That's our first goal. We want to deal with our parentheses. So we look at inside parentheses first. We always want to work from the inside outward. So we look at this inside parentheses first. So first thing we can do is we can distribute the negative 7 into the x plus 2. So let's rewrite everything as 3x minus 5, bracket still there, 4x. But now I have negative 7 times x, negative 7x, negative 7 times 2, negative 14, and I close bracket. So 106. So now our parentheses are gone because we just used the distribution law to get rid of them. Now we're still working inside of parentheses, or brackets in this case. We look at inside, what can we combine? We see that we have a 4x minus 7x. So that can be combined. So we will write this as 3x minus 5, bracket, 4x minus 7x gets us negative 3x, minus 14, close bracket, equals to 106. So now we look inside our bracket one last time and see, can we do anything else? In this case we can't, because 3x and 14, we can't combine them. So we move on to our outside, which is a multiplication. So this multiplication is another distribution. I distribute negative 5 into everything inside my bracket. So I have 3x plus 15x. And then negative 5 times negative 14 is positive 70 equals 106. Right? So now I see I can consolidate my 3x and 15x. I can combine them. It gives me 18x plus 70 equals 106. And to solve for x, I want to get x by itself. So I subtract both sides by 70 to get rid of that positive 70. 106 minus 70 is 36. So 18x equals 36. And my last step is to divide by 18. So divide both sides by 18. Again, x equals 2. X is 2. So let's check if that is our answer. Right? X equals 2. Okay. Alright. So we're done with our linear equations now. Now we move on to probability and statistics. So probability and statistics is a lot of just knowing the definitions. There's not much arithmetic to it. It's knowing the definitions and knowing which one to apply. So these definitions are provided for you inside your math packets. So we'll move on to that and just be sure to refer back to them whenever you need to. Okay? So these are more definitions. So let's do some of these, right? Now, range. Consider the following 12 data points, 10, 12, 10, 18, 16, 15, 9, 14, 11, 13, 12, and 16. What is the range? So range, right? Range is all we're doing is we're looking at what's the biggest number out of all our numbers, our set of data. Our biggest number would be 18. So the range, you remember that the range, the definition, is you take the biggest number, subtract by the smallest number. So the biggest number is 18. And we subtract, our smallest number is 9. So it's 18 minus 9. And we know that would just be 9. So the range would be just 9. Right? Let's find out what's the answer. There we go. Range is 9. Okay. Now, probability. So, like your definition says, the probability is the chances of you getting something. The chances of you rolling a dice, flipping a coin, stuff like that. So we look, what's the probability that the number, a fair dice is rolled, what's the probability that the number shown is not 4? So, we have a dice, right? We know a dice is labeled 1 through 6. So these are the faces of our dice. 1, 2, 3, 4, 5, and 6. Now we're looking for the probability of it being not 4, right? So we look at what faces are not 4, right? So first off, we know probability is always a fraction. And the top of the fraction is the chance of it not being 4, the number of outcomes it not being 4, and the bottom is the total number of outcomes in general. So the total number of outcomes is 6 sides, because we have 6 sides of a dice. The top of it is we look at what is not 4. Which sides are not 4? So we have 1, 2, 3, 5, and 6. Those are 5 sides that are not 4. So the probability of not being 4 is just 5 over 6, which is a good chance. Right? Five over 6. Right, so moving on. So another one. So we know the fair dice. This time, what's the probability that shows a number multiple of 3? Multiple. So let's do the same thing. We have our numbers, our side of our dice. So this time it's a probability of it being a multiple of 3, right? So multiple of 3 is any number that can be divided by 3. So we look at the numbers we can divide by 3. We know we can divide 3 by 3, and we can divide 6 by 3, right? So, our fraction The bottom is still going to be 6 because that's the number of sides our dice has. And we look at how many of them are multiple 3s. 2 of them out of a total of 6. But again, we always want to reduce our fractions if we can. 2 over 6, okay, you can divide both top and bottom by 2. You get 1 over 3. So our answer, the chances of getting a side that's multiple of 3 is 1 over 3. Okay. So 1 over 3. Okay. Let's do another. Now, this time we're talking about cards. So a card is drawn randomly from a deck of ordinary playing cards. You win $10 if the card is a spade or an ace. What is the probability that you will win the game, right? So, first up we want to see what is considered extra information. The extra information is the $10 here. Because the question is asking, they don't care how much money you're winning. They're saying, what are your chances of winning, right? So, right away we just get rid of the $10. We just ignore that. Now, they're saying you'll win the game if it's a card is a spade or an ace, right? So this is knowing a little bit about a deck of cards. So let's look at this. So we have a deck of cards. So a deck of cards, a standard deck, is always 52 cards. It's split up into 4 suits. 4 suits. And the suits are spades, clubs, hearts, and diamonds. And each of those suits have 13 cards. 13 for each suit. And they'll all just be the same cards, just in different suits. Those cards are labeled 2 through 10. Those are our number cards. And then we have some face cards. We have Jack, Queen, King, and Ace, right? Those are the cards that we have. Those are our face cards. So now, looking back, we say that we're looking for the probability of it being a spade or an ace. So we look. I underline or. Why do I underline or? Because in probabilities, or is always represented. You always think about adding. And if you were to see and, that's considered multiplying. So or means adding, and means multiplying. So we look at the probability of spade or an ace. That can be represented by writing probability spade separately, plus, because we're talking about or, probability of ace. So now we think about what's the probability of spades and ace. So let's look at the probability of spades first. We said probability, it's a total of 52 cards, but then 13 of them are aces. So we put a 13 on top here. Now plus. Now look about aces, right? Aces is, I know these cards repeat every suit. Now we look at it, ace, there should be one ace in every single suit. So we have an ace of spades, ace of clubs, ace of hearts, and ace of diamonds. But our ace of spades is already sitting in this 13 here. It's one of those 13 cards. So that means we don't include the ace of spades as our ace probability here. That means that we look at the remaining ones. The remaining aces are ace of clubs, ace of hearts, and ace of diamonds. So there's only 3 left out of those 52 total cards, because we already used ace of spades. So from there, because our denominators are the same, we can just add them. So 13 plus 3 gives us 16 over 52, which then can be reduced. They both divisible by 4, so if I divide by 4, I get 4 over 13. So my chances of winning the game is if I get a spade or an ace, is 4 out of 13. Okay. So you want to remember that whenever you see probability questions and you see or, that always means addition, and always means multiplication. Right. So let's see, that's our answer. 4 over 13. There you go. Okay. So let's move on. Now we're going back to the statistics problems. So we're talking about mean this time, right? So find the mean of the data in the following table. So we have a table here. So the table, we have to interpret this table and understand what is going on. What the table says is that the left column is our grades. The right column is a number of people who got those grades. So we say that 4 people got 100, 3 people got 98s, 2 people got 95s, and 1 person got an 86. So find the mean. So find the mean, when we're talking about mean is we're talking about average, right? The average of things. So to find the average is you add up all the numbers and you divide it by however many there are. So the mean of this table. So first off, let's say what we're dividing by, right? We're dividing by the total number of grades. So what it is there's 400s, 398s, 295s, and 186. So what we're doing is we're adding up these numbers on the right here, because those are how many students got those grades. So we have 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. Now we do is we add up all the actual numbers, right? So we have 400s. So instead of writing 100 4 times, I can write this as 4 times 100. That serves the same purpose. Same thing when I do 3 times 98 plus 2 times 95 plus 1 times 86. Extend that division side over. So now if I were to, again, you'll probably be allowed to calculate for this type of question. If you add up all the top, you should get 970. And if you divide that by 10, your mean, divided by 10, your mean should be, the 10s cancel, they'll have just 97. So the mean, the average of all the grades would be a 97. Let's see, that's our answer. There we go. 97, right? Okay. So, let's look at the same set of data, same thing, physics grades, but this time it says find the mode of the data in the following table. So the mode, all it is the mode is the number that shows up the most frequently shown number. So we look at it, if out of all the numbers that show up the most, 100 is the one that shows up. So the mode would be the number that shows up the most is just 100. So our mode is just 100. Right? So there's not much calculation for this one. All you do is you have to interpret the data. You look at the data and you see that what is the most recurring number, which is 100 in my case. There we go. Okay. And the last one of these is, we're talking still same set of data, but this time median, right? So find the median of data in the following table. So what median is you order them from ascending or descending order, so greatest to least or least to greatest. So since it's written like this, let's order from greatest to least. So we have 400s. We have 398s. We have 295s. And then we have 186. Okay, so now in order to find the median, what you do is you start, what I like to do, I start crossing both sides. You want to cross an even amount until you get to the middle. So if I cross one to the left, I cross one to the right, one on the left again, right, one on the left, one on the right, and then one on the left, one on the right. So I end up with 2 numbers in the middle. And you should have 2 numbers in it because by the definition of a median is if your data set has an even amount of numbers, in this case we have 10, there should always be 2 numbers in the middle, right? So how do we find the median if there are 2 numbers in the middle? So by definition, if there are 2 numbers in the middle, what you do is you find the average of them. So you do is you take the 2 numbers, you add them up, and you divide them by 2. But in our case, both the numbers are 98s. So I can write this as 2 times 98, because that serves the same purpose as adding up 2 98s, and then I divide. I see that 2's can cancel, I'm left with just 98. So our median is just the middle number of all the numbers we have is just 98. Okay. Right? So, median is 98. Alright, so that concludes the section for today. Next time we'll be doing factoring and quadratic equations. Right?